This subtraction strategy is called compensation, and in this strategy the goal is to make a problem that is easier to solve mentally or in our heads. So before we use compensation to solve these two problems, let's take a look at why compensation works. So looking at a simpler subtraction problem, such as 8 minus 5, we know that when we are subtracting, we are finding the difference between two numbers. And the difference is how much longer one number is or how much shorter one number is. So if we are trying to find the difference between 8 and 5, we would subtract 8 minus 5 to get the difference 3. Then we learned that if we add the same amount to both numbers, that the difference remains the same. So if I add 2 to both of these numbers, my numbers then change to 10 and 7. So the difference between 10 and 7, 10 minus 7, is still 3. So again, adding the same number to both numbers, or adding the same amount to both numbers, keeps the difference the same. So we're going to use this concept and we're going to apply it with some more challenging problems and larger numbers. So our first problem, 54 minus 29, that's not something that's really easy for our kids to solve in their heads or mentally. So we want to make an easier problem that they can solve mentally. So I like to start out with a tape diagram. It just makes the numbers visual. It helps represent the numbers in a visual way. So we have 54, and the part that we know is 29. We're looking for this missing part right here. We know 29 and something else will make 54. So 54 minus 29 will give us this missing part. Like I said, 54 minus 29, not very easy to do mentally. We are going to add the same amount to both numbers to make the problem easier. So 29 only needs one more to make a friendly number, or a multiple of 10. 29 and 1 make 30. If I add 1 to this number, I have to add the same amount to my other number. Just like we did with our cubes, we have to add the same amount to both numbers for the difference to stay the same. So 54 plus 1 is 55. So now instead of 54 minus 29, we have an easier problem. 55 minus 30. And this is a problem that our kiddos can solve in their heads. They can mentally subtract 3 tens from these 5 tens. They know 5 tens minus 3 tens is 2 tens, and then we have 5 ones that we did not subtract. They start with 55 and take away 3 tens. 45, 35, 25. Let's use the same strategy to solve 66 minus 28. So again, I'm going to start with a tape diagram. This represents 66. This represents 28. We are looking for the difference. So 66 minus 28, not very easy to solve mentally. So we want to make it an easier problem. I know 28 only needs 2 more to make a multiple of 10. So if I add 2 to this number, I need to add 2 to the other number. 28 plus 2 equals 30. 66 plus 2 equals 68. Now instead of 66 minus 28, we have an easier problem. We have 68 minus 30. 6 tens minus 3 tens will be 3 tens. And then we have 8 ones that we did not subtract. 68 minus 3 tens, 58, 48, 38. Basically what we did, we made an easier problem. We wanted 28 to become a friendly number, something easier to subtract in our heads. We wanted it to be 30, so we added 2 to make 30. If we add 2 to this number, we have to add 2 to this number for the difference to stay the same. So the problem became 68 minus 30. And that is how you use the compensation strategy to subtract.